Python code can seem confusing at first, but once you understand functions, everything becomes much more organized. In this video, we're going to go through every example step by step and explain exactly what each part of the code does. By the end, you'll know how to create your own functions, pass information into them, and get results back. Our first example creates a very simple function named greet. The word def tells Python that we are creating a new function. Right after def comes the function's name, which is greet. The parentheses are empty because this function doesn't need any information to work. The colon tells Python that the instructions for the function are about to begin. Inside the function is a print statement that displays the words, "Hello, Python." Whenever the function is called by writing its name followed by parentheses, Python runs the code inside it. Since the function is called twice, the message appears on the screen 2 times. This demonstrates one of the biggest advantages of functions. Write the code once, use it as many times as you want. The next example compares a function to a machine. This function is called add, and it has 2 parameters named a and b. Parameters are placeholders that will receive values whenever the function is used. Inside the function, Python adds the 2 numbers together and stores the answer in a variable called result. The return statement sends that answer back to the program. When the function is called with the numbers 3 and 5, Python places 3 into A, 5 into B, calculates the sum, and returns the answer, which is 8. The print statement then displays that returned value. Python includes many built-in functions that you can use without creating them yourself. The len function counts how many characters are inside a piece of text. The type function tells you what kind of data something is, such as a string or an integer. The max function finds the largest value from a group of numbers, while min finds the smallest. The print function displays information on the screen. These built-in functions save programmers time because they are already written and tested. The next slide shows why functions reduce repetition. Without a function, you would have to write the same calculation again and again. Here, a function named square accepts one parameter called n. The return statement multiplies n by itself to find its square. When the function is called with the numbers 2, 5, and 10, Python performs the same calculation each time without rewriting the formula. The results are 4, 25, and 100. This shows how one function can solve the same type of problem for many different values. Choosing good names is important. The function called calculate_total clearly tells us what it does. A name like thing1 gives us almost no information. When working on larger programs, meaningful names make code easier to understand and maintain. Other programmers should be able to guess what a function does simply by reading its name. Calling a function is very simple. Once the function has been created, you simply write its name followed by parentheses. Each time the name is called, Python jumps to the function, runs all of its instructions, and then returns to continue running the rest of the program. If the function prints a message, that message appears every single time it is called. Parameters act like variables that are created only for the function. In the example, the parameter called name doesn't have a value until the function is used. When the function is called, Python temporarily stores the provided value inside that parameter. This allows the same function to work with many different pieces of information instead of being limited to just one. Arguments are the actual values given to a function. If the function has a parameter named name, then calling the function with the word Alice means that Alice becomes the argument. Python copies the argument into the parameter before running the code inside the function. The parameter is the placeholder, while the argument is the real value. Some functions return values. In the next example, the function add returns the sum of two numbers. Instead of printing the answer immediately, the returned value is stored in a variable called result. That variable can then be printed, used in another calculation, or even passed into another function. Returning values makes functions much more flexible because the answer can be used anywhere in the program. Not every function needs a return statement. Some functions simply perform an action. In this example, the function prints the message, "Have a great day." Since its job is only to display text, it doesn't need to return anything. Functions that perform actions are just as useful as functions that calculate values. Code reuse is one of the biggest reasons programmers use functions. In the area of a circle example, the formula is written only once inside the function. Whenever you want the area for a different radius, you simply call the function with a new value. The function performs the same calculation each time, saving time and preventing mistakes. Functions also improve organization. Instead of putting every instruction into one giant program, we split the work into smaller functions like read_file, process_data, and save_file. Each function has one specific job. When combined, they complete a larger task. This makes programs easier to read because each section has a clear purpose. Smaller functions also make debugging easier. If a program gives the wrong answer, you only need to check the function responsible for that task instead of searching through hundreds of lines of code. Since each function focuses on one job, mistakes are much easier to find and correct. Functions make teamwork possible. One programmer might create the login function, another might design the sign-up function, while another creates the password reset function. Since each function performs a different task, everyone can work at the same time without interfering with one another's code. Later, all of the functions are combined into one complete program. Functions can also call other functions. In this example, a function named double_square uses another function named square. First, square calculates the square of a number, then double_square takes that result and doubles it. Breaking large problems into smaller functions makes programs easier to understand and much easier to expand. Default parameters make functions more flexible. In the greeting example, the parameter name has a default value of guest. If no argument is provided, Python automatically uses guest. If another name is given, Python replaces the default value with the new one. This allows one function to work in multiple situations without requiring every argument every time. Functions can also accept multiple parameters. The add_numbers function receives three numbers named A, B, and C. Inside the function, Python adds them together and returns the total. When the function is called with 2, 4, and 6, the answer is 12. Using multiple parameters allows one function to solve more complex problems while staying organized. Functions are used everywhere in programming. Websites use functions to display pages and process user information. Games use functions to move characters, detect collisions, and calculate scores. Data analysis programs use functions to organize and process information. Artificial intelligence systems also rely heavily on functions to perform calculations and make predictions. Almost every program you use today contains thousands or even millions of function calls. Before we finish, Let's review the most important ideas. A function is a reusable block of code that performs a specific task. The def keyword creates a function. Parameters receive information, while arguments are the actual values provided. The return statement sends a value back to the program. Functions reduce repetition, improve organization, simplify debugging, and make teamwork easier. Learning functions is one of the biggest steps toward writing professional Python programs. Now you understand not only what functions are, but also how every piece of the example code works. Keep practicing by creating your own functions, experimenting with different parameters, and returning different values. The more functions you write, the more natural Python programming will become, and you'll be ready to build much larger and more advanced projects.